Today we're going to be talking about coordinate proofs. And coordinate proofs are ways that we can use the distance, the midpoint, and the slope formula to prove that a shape or that a set of 4 points creates a given shape. So what we're going to be doing is we're going to be talking about parallelograms and using the slope, distance, and midpoint formula to show that the shape that we're talking about is in fact a parallelogram. So remember that in a parallelogram, opposite sides are parallel, so that means that parallel sides must have the same slope. If we're trying to figure out if sides are parallel, we want to use a slope formula. Remember that is m equals y2 minus y1 over x2 minus x1. Then adjacent sides are perpendicular. Remember, perpendicular means that you have a right angle. So sides, perpendicular sides must have slopes that are opposite reciprocals. And again, we use a slope formula for that. Opposite sides are congruent. We use the distance formula because we're talking about the length of a segment. So distance equals x2 minus x1 squared plus y2 minus y1. Sorry, y2 minus y1 squared. And then if the diagonals bisect each other, remember bisect means we cut something in half. So that means they should have the same midpoint. So we would use the midpoint formula. x1 plus x2 over 2, comma y1 plus y2 over 2. So if we look down here, remember that in a parallelogram, it's a quadrilateral where opposite sides are parallel. So if this is a parallelogram, PQ and RS are parallel, that's what this means, and QR and PS are parallel. QR is parallel to PS. So we're going to write a coordinate proof to show that this, in fact, down here is a parallelogram. So we have the coordinates that were assigned to this problem. Now we're going to prove that both pairs of opposite sides are parallel. So we're going to find the slope of these two sides, xw and yz, and they should be the same. And then we're going to find the slope of xy and wz, and those should be the same as well. So see the slope of wx is equal to, remember we're going to do x1, y1, x2, y2. And again, it doesn't matter which ones you label x1, y1, x2, y2. So y2, 0 minus y1d over 0 minus c. That equals negative d over negative c, or positive d over positive c, because a negative divided by a negative is a positive number. Now we're going to find the slope of zy. So x1, y1, x2, y2. So y2 is d minus y1, which is 0, over x2, c plus b, minus x1, which is b. So we have in the numerator d over c plus b minus b, where the positive b and negative b cancel, and we're left with c. So these two segments have the same slope, so those two segments are parallel. Now let's look at the slope of xy. Well, because it's a horizontal line, we know that has a slope of 0. And then the slope of WZ is also another horizontal line that is also 0. So both pairs of opposite sides are parallel. So this is a parallelogram. Both pairs of opposite sides are parallel. So that's one way to show that a shape is a parallelogram. So let's go down here. Prove that both pairs of opposite sides are congruent. So we're going to be doing the distance formula for all 4 sides. Okay, so let's go down here. The horizontal lines, X, Y, and WZ, because those are horizontal, we can just count. Or we can do the subtracting from the X coordinates. Or you could use a distance formula. You would get the same answer. But we want to make work easy when we can. So XY is going to be CB minus C. CB, C plus B minus B. Sorry, minus C. So you have C plus B and then minus C. These cancel off, we're left with B. And then we have WZ. And again, that line is horizontal. If we go back up and look at it, we will see that it is a horizontal line. And you can say, well, my X values go from 0 to B, so that distance is also B. So we showed that those 2 sides are congruent. Now we have to do YZ, and that's going to be the distance formula. And we already have it labeled x1, y1, x2, y2 from doing the slope. So x2 minus x1, so CB minus B. C plus B minus B squared plus D minus 0 squared. Again, I'm using the distance formula between Y and Z. And this is going to equal C plus B minus B. Is this going to be C? So we have C squared plus D squared. And we can't simplify that any further. WX. Because this is 0, that makes life a lot easier. So that's going to be 0 minus C squared plus 0 minus D squared. That's going to give us negative C squared plus negative D squared. Remember, when you square a negative number, it becomes positive. So that's going to be C squared plus D squared. And that is the exact same as we got up here. So we know that the opposite sides are congruent. So that's another way to show that this is a parallelogram. Prove that the diagonals bisect each other. So now we're going to find the midpoint of the diagonals. I'm going to erase my labels right here because now I'm going to have new x1s and y1s. I want to find the midpoint of these 2 segments, and they should be the same. The midpoint of my brown line and the midpoint of the light blue line should be the same. So x1, y1, x2, y2, and then in brown, x1, y1, x2, y2. So we're going to do the brown one first. The midpoint. So x1 plus x2, so 0 plus C plus B. 0 plus c plus b over 2, comma, 0 plus d over 2, which is going to be c plus b over 2, comma, d over 2. And we can't simplify that any further, so we're going to leave that there. Then we're going to find the midpoint of xz. This is xz. Up here was wy. We do this little notation down here so that we can go back and verify, remember what segments we are looking at. So we're going to do c plus b, because we're x1 plus x2, c plus b over 2, comma, it was d plus 0 over 2, which is going to be c plus b over 2, comma, d over 2. And we showed that the midpoints are the same, which is what should happen in a parallelogram. We're going to skip finding the lengths of the diagonals. If you were to do that, you would see that the diagonals are not the same length. So a couple ways that you could prove that something is a parallelogram, and you don't have to do all of these. You could just do one of these, and it would be good enough. You could show that both sides are parallel, like we did at the very beginning, using the slope formula. You could do the distance formula and show that both pairs of opposite sides are congruent. So that means using the distance formula 4 times. You could show that both pairs of opposite angles are congruent. That's harder to do with what we're doing right now, but it's possible. You could show that one pair of opposite sides are congruent and parallel. So you could find the slope of one pair of opposite sides and the distance of one pair of opposite sides. And if they're the same, then it's a parallelogram. But my favorite is show that the diagonals bisect each other. That's using the midpoint formula. And the midpoint formula is easy for us to do. And that's what we did right here in letter D. That did not take much work at all. We just had to do 2 calculations. And if they have the same midpoint, then it is a parallelogram. So we're going to be expanding on this in the next couple days, but it's important to be able to do the slope, distance, and midpoint formula, and then remembering our properties of not just parallelograms, but rectangles, kites, squares, like all the quadrilaterals that we talked about. So like I said, we're going to expand on this a little bit further, but this was just an introduction. So thanks for watching. Make sure to like the video and subscribe.